Department of Chemistry. Today my topic is chemical bonding. What is bond? A chemical bond may be defined as the force of attraction between any two atoms in a molecule to form chemical compounds which stabilize the atoms. Types of bonds: covalent bond, ionic bond, coordinate bond. These are present in the types of bonds. Covalent bond: mutual sharing of one or more pairs of electrons between two combining atoms results in the formation of chemical bond is called covalent bond. Example: two hydrogen atoms combine to form the covalent bond. This is called the covalent bond. Ionic bond. Ionic bond also called electrovalent bond. Type of linkage formed from the electrostatic attraction between oppositely charged ions in a chemical compound. Example: sodium is the positive ion, chlorine is the negative ion. The sodium donates the electrons to the chlorine to form the ionic bond. Coordinate bond. A coordinate bond is type of alternate covalent bond that formed the sharing of electrons from the single atom. Both shared electrons are donated by the same atom. It is also called a dative bond or dipolar bond. Example: nitrogen has the lone pair of electrons. It donates the electrons to the electron deficient species like hydrogen to form the covalent bond or covalent coordinate bond. Bonding parameters. Four types of bonding parameters are present. First one is bond length, bond order, bond angle, and bond enthalpy. Bond length. Bond length is a measure of distance between the nuclei of the two chemically bonded atoms in a molecule. It is approximately equal to the sum of covalent radii of two bonded atoms. These are the two bonded atoms. This one is the center. This one is another atom center. This distance is called as the bond length. Bond order. Bond order of the covalent bond is the total number of covalently bonded electrons pairs between the two atoms in a molecule. This is the example: number of bonds between the molecules. This carbon-carbon condenses triple bond. This is called the bond order. Number of bonds is 3. Next, bond angle. Bond angle can be defined as the angle formed between two covalently originated from the same atom. The geometrical angle between any two adjacent covalent bonds is called the bond angle. This is called the bond angle. It is an example of the bond angle water molecule. Bond enthalpy. It is defined as the minimum amount of energy required to break one mole of particular bond in molecules in the gaseous state. The unit of bond enthalpy is kilojoule per mole. Sigma bond. The covalent bond formed by the axial overlap of atomic orbital is called sigma bond. These two atomic orbitals overlap with headed or axial overlap. This is called the sigma bond. Pi bond. Pi bonds are formed by the sideways positive or safe phase overlap of atomic orbitals along a direction perpendicular in the internuclear axis. This is the pi bond. Perpendicular overlap is called the pi bond. Hybridization. Redistribution of the energy of orbitals of individual atoms to give the orbital of equivalent energy happens when two atomic orbitals combine to form a hybrid orbital in a molecule. This process is called the hybridization. Hybridization examples are sp, sp2, sp3 and sp3d, the sp3d2. These are the hybridizations of examples. Next one is the valence bond theory. Valence bond theory. Electrons in a molecule occupy atomic orbitals rather than molecular orbitals. The overlapping of atomic orbitals results in the formation of chemical bond, and the electrons are localized in the bond region due to overlapping. Postulates. The overlapping of two half-filled valence orbitals of two dissimilar atoms affects the development of the covalent bond. The overlapping causes the electron density between bonded atoms to rise. This gives the properties of stability to the atom. In case the atomic orbitals own more than one unpaired electrons, more than one bond can be made. Paired electrons in the valence shell cannot take part in such bond development. A covalent bond is directional. Such a bond is similar to the region intersecting atomic orbitals. Based on the design of overlapping, there are two kinds of two kinds of covalent bond, pi bond and a sigma bond. Application. The maximum overlap condition, which is described by the valence bond theory, can explain the formation of covalent bond in several molecules. For example, the difference in length and strength of chemical bonds in H2 and F2 molecules can explain by the difference in following orbitals in these molecules. Limitations. Failure to explain the tetravalence exhibited by carbon. No insight is offered on the energies of the electrons. Their theory assumes that electrons are localized in the specific areas. It does not give a quantitative interpretation of the thermodynamic or kinetic stabilities of coordination compounds. No distinction between weak and strong ligands. No explanation for the color exhibited by coordination compounds. Today talk about the topic is chemical bonding and the types and their parameters. And thank you.